Okay, good morning. Can everyone still hear me? All right. Welcome, day 2 of Texas Linux Fest. I'm really excited to be here. This is my second Texas Linux Festival. I came last year, was really blown away by some of the conversations, so I figured I'd come and give one. So shout out to all the event organizers for letting me come to Texas Linux Fest and talk about something that isn't Linux. If you didn't know, you're going to talk about something that isn't Linux. We're going to talk about the Darwin operating system. Along the way, we'll talk about some of parallel operating systems, BSDs. Most folks here will probably be at least familiar in name with some of those systems. So. All right, let's get started. So it's impossible to talk about an operating system in 45 minutes, so you're just going to get the highlights, just the bits and portions that I think are important. This is a condensed presentation. I have a 3-hour-long lecture, and I'm working on a book, and I'm trying to figure out how to get it under 2,000 pages, but Apple keeps releasing changes to their operating system every year. It makes it really difficult. But initially, wanting to start out here, we're going to have some history. There's going to be no code in this presentation. I took it all out last night. Code changes, abstractions live on. But to get started, this quote from Ken Thompson is one of my favorites. In computer science, we tend to think of systems as being these things that are developed separately, apart from each other. That really is not the case. When Linux came to be, Linus Torvalds was very familiar with the BSD operating systems. He had worked on a Minix operating system in college. These things are all really inspired by each other, and so you're going to see a lot of the same implementations, the same abstractions. Things will more or less be done the same way, especially with the open source systems. They all run on the same processors. They have to abstract the hardware more or less kind of equally. A little bit of my background. So I live in Crowley, Texas, about 2.5 hours from here. It's just south of Fort Worth. Most people have never heard of it. It's kind of out in the middle of nowhere. I came up through the NSA. When I was 18, the NSA recruited me. They had me take some tests and said, hey, you're great with computers. We'd love you to come join our hacking organization where you can focus on kernel exploitation. So if it runs a kernel, I've exploited it. Full-time husband and father, so when I'm not doing computer stuff, I'm with the kids. I've got the kids working on some little Linux projects, some Scratch on their Raspberry Pi. My skill set, when I'm not hacking, I'm a low-level software engineer, lots of device drivers, operating system policy, application and system hardening, particularly familiar with, again, BSD-style kernels, of which Darwin is one. We'll find out here shortly. And the communities, FreeBSD mostly. I dibble-dabble in OpenBSD. I do have a few clients who really want some best-of-breed security solutions. Apple's open source community, the Objective-C Foundation, they do a lot of GPL license work. If you're ever looking for anything security, looking in Apple's ecosystem, they're the folks you probably want to talk to. And then I volunteer with the FBI InfoGuard up at the Dallas office. So we've worked to do some crazy stuff. We found, access points connected to the internet that controlled water valves with chemicals that more than likely should not be connected to the internet. So agenda, we're going to keep it super simple. We're going to talk a little bit about the history of these technologies. It's super important to figure out where they've been. Again, as I said earlier, code changes, abstractions remain. We'll jump into Apple's X and U kernel. That stands for X is not Unix, even though it's one of the few certified Unix operating systems. And then we'll talk a little bit about Apple's userland. And from there, we'll make some comparisons to the Linux I'm most familiar with is Red Hat and Fedora. So I kind of kept that in mind when I drew some of these parallels, as you'll see in the slides. All right, let's start with history. So I'm seeing a lot of young faces in here who maybe weren't alive for the Unix wars, but there was this time in the 80s and 90s where different Unix standards competed against each other to try to be the Unix. Turns out the answer was Linux. Linux wasn't even around at this time. If you were around at this time, you either remember this as a time of great innovation or a time of despair, because all of these operating systems that competed kind of did things just a little bit differently. And that opened the door for Windows to kind of come through and steamroll Unix for a number of years. It's likely the reason why today most people are more familiar with Windows, or your average person's familiar with Windows and not some Unix variation. So there were a bunch of systems at the time, Digital Unix, Solaris, Linux, again, Linux came a little bit later. System 5 Unix, Unix proper from AT&T, again, different folks trying to do different things. Along the way, standards committees came up trying to consolidate these really into a set of standards that folks could implement, so you could know, hey, I could write my software for Solaris, pick it up, throw it on BSD, and it would just run. That kind of failed, it kind of didn't. We still do use the POSIX standards today. The BSDs, particularly FreeBSD, tries to be very POSIX compliant. Linux is there too. I don't know how many developers nowadays. I think folks are just using the libraries. I'm not sure how much POSIX really factors in. Long story short, though, this kind of weakened the community. Most of these operating systems are gone in the sense that someone somewhere is still using them, but they're not being used widely anywhere. Okay, so kind of where we are at the time, the Unix wars. We have the 4BSD project, which is a trusted computing base. It's really similar to Linux. If you've never heard of the 4BSD project, it was funded by DARPA up at Berkeley. The BSD stands for Berkeley Software Distribution. And it's where we got some of the fundamental enhancements for Unix. At one point, this wasn't actually a standalone operating system. It was a set of enhancements to what AT&T had with Unix. They were barred by the federal government from competing directly in operating systems. They had a whole monopoly with telephones and some other stuff going on. And so they gave it away for essentially free. The folks at Berkeley took it, figured there were some things they could do better, and modified it, and we ended up with 4BSD. Unlike Unix, or excuse me, Linux, the BSDs, of which there are many descendants, they are not distributions. They are each their own kernel and their own user land. They do have a common ancestor, so they're largely compatible, but not entirely. In terms of implementation, so if you looked at the BSD kernel, it looks a lot like Linux. It implements some different standards, things like new bus, auto configuration. The folks who work on these come from an academic background, and if there is a standard, they'll normally try to implement it, even if they're the only operating system implementing it. But if you learned BSD or Linux, you could learn the other kernel in a matter of months. The first one is kind of the hardest. After that, there's only so many ways to abstract away a character interface. Mach. Has anyone here never heard of Mach? Couple of hands, okay. Well, so Mach was the microkernel project right next to Minix in the 80s and 90s. And it has a very long history. Its technologies originated in the 60s. The folks who worked on it in the 80s and 90s, again, another project funded by the US government. They normally when DARPA funds things, they don't just do one thing. They try to do 2 or 3, let them compete, see which one comes out on top. This was one of the other systems. It's based on a system from RIG from Rochester up in New York from like the 50s, 60s. It wasn't very Unix compatible, moved on to Accent and then to Mach. And when folks looked at Mach, they said, hey, if we want to be successful, we have to be Unix. Our underpinnings can be different, but ultimately the world software at that time ran on Unix. So this is also a while ago. So you will see that parallelism, symmetric multiprocessing, was just becoming a thing. This was back when there was really one CPU core on the chipset. And so Mach largely failed. A number of people did try to do projects based on Mach. Everyone here, I'm sure, has heard of the GNU, the Free Software Foundation. Their original plan was to build their own kernel. Linux came a little bit later. They were building their kernel, and they, I believe, still are. The GNU Herd project, someone somewhere is still working on that. That is a Mach-based system. Just no one uses it. Along the way, Apple at the time was struggling. This is 80s, 90s. Apple was really not doing well. They started an internal project to take the Mach microkernel and implement it under Linux. Actually put something out. There's still source code available. You can go online and download something called MK Linux. It's just Linux implemented on top of a microkernel. The thing about microkernels, I think the designers at the time, very familiar with Unix, saw that the kernel would continue to grow. The kernel has continued to grow. It actually ends up being just a lot of its hardware support, different device drivers. But in the 80s, 90s, if you're thinking this thing is going to grow at the same rate it's been growing, you probably want to refocus your efforts and say, hey, let's have a small base kernel, does the hardware abstraction, does all that kind of stuff, and then we'll let user space implement the Unix process model, device drivers, things like that. So small kernel focused, technically marvelous, again, largely failed. Today, XNU is the only widely deployed system based on Mach. But a lot of research came out of this. Classic Mac OS. So this is, anyone here use Mac OS before Mac OS 10? Okay, so some more hands for that. So this is the Mac OS that wasn't based on Unix. anyone who used this kind of knows it really wasn't that great. At the time, the folks working at Apple, again, didn't really come from an academic background, weren't super familiar with Unix at that time, and then the hardware just wasn't there. Many PCs didn't have the virtual memory protections that we're used to today. It was really hard to get Unix running on it. It'd be like today trying to get Linux running on a microcontroller. It can be done, it's just not easy. So Apple at the time was in the need, looking for a kernel. They looked around, they saw that there was the BSD project. Again, Linux at this point wasn't quite yet a thing. They had their classic Mac OS technology. The problem at hand was, how do you take the classic Mac OS technology, which has hundreds, thousands at the time of applications written for it, and translate it over to something that also had thousands of applications written for it, Unix. And we end up with Next Step. There was a company who did just that. The lead researcher from Mach, Avi Tevanian, at Carnegie Mellon, Apple picked him up after the DARPA funding ended, brought him over and said, hey, we really love your technology. At the time, Next Step, the early core, was written on 4.3 BSD that had the networking release technology. They layered it on top of Mac and started a company called Next Step. Made a super advanced operating system. Had an Objective-C, object-oriented driver API, which we haven't seen too many other operating systems adopt at this point. Tried to do their own hardware, ultimately failed. They were bought by Apple. Apple took their kernel technology. They stopped their work on Apple's Copeland and MK Linux and all that stuff, and along comes Darwin. And so here we are. Oh, you know, and I forgot to mention, few slides back, this little red guy in the corner, this is the FreeBSD daemon. His name is Beastie. He was the unofficial icon for a number of years. When you move forward to Darwin, you can kind of see the resemblance. The name of the operating system comes from that history. Apple took what was probably 3 or 4 distinct systems, mashed them together, and said, here you guys go. This is our Unix. So the Mach microkernel is the base of the Darwin operating system. They've layered a BSD on top. It's not a particular BSD. Folks in the BSD community would tell you it's FreeBSD. It's very similar. It shares a lot of code. It is not FreeBSD. There's enough different with the operating system that I, having studied both, would not call them one and the same, but they are very, very similar. Classic Mac OS, and then that object-oriented API was upgraded to C++, if you can consider C++ an upgrade. And renamed IOKit. And so developers now, instead of having to write raw character interfaces, you get these objects that you get to send messages to. So that's most of the history here. Now let's move on to the XNU kernel proper, and we'll look at how it actually integrates these technologies. First things first, it's Apple's playground. So XNU is semi-open source, right? You can go to opensource.apple.com. You can download the code, it just won't run on anything. Apple does not include the bits that they consider proprietary, a lot of that being their custom hardware bits, security policies, and then just some code that we can't figure out why it's not open source. And if you ask Apple, they're not going to tell you. In 2019, all of us kernel developers got kicked out of the kernel. Apple, after about 20 years, said they finally figured out how to integrate the Mach object-oriented kind of everything as a user space service operating system design into the larger kernel. It works, and as we'll see later, there's some trade-offs, but now everything runs in user space. If you're anyone here running an iPad or a MacBook, brought one with you, a couple of people in the back, yeah, so today, no kernel developer, you're not running any third-party kernel code in your system. And much like Google, there is a GitHub for the XNU kernel, even the Darwin operating system. You can open a PR, Apple just won't ever look at it. Okay, so XNU Mach, and I have this great book. This book only exists physically. I might have 2 of like the last copies in the world, but it's called Programming Under Mach. It really explains, this is a slightly different version of Mach. Alongside the Free Software Foundation, known for GNU, there was a second foundation called the Open Source Foundation, which had the nickname the Oppose Sun Forever Foundation, because at the time, Sun with Sun OS and Solaris were really dominating the Unix landscape. Oh, sorry, there we go, Open Software Foundation, thank you. And A lot of folks in the Open Software Foundation, one of the agreements to be in that group was that you were going to base your system off of Mach. And I believe DEC did. They produced a Mach-based Unix, digital Unix, which, again, still runs somewhere on some systems, not widely used. So from Mach, we get the lower half of the kernel, which is kind of similar to the part of the Linux kernel that you would call the dark magic, the thing that actually abstracts away the hardware, brings the processor up, those bits. That's all Mach for the Darwin and the XNU kernel. The key abstractions, ports, which is a really big abstraction. The code behind that has changed over the years. That abstraction still remains today and is probably the most fundamental abstraction for any Mach-based system. Mach messages, microkernels, they do interprocess communication. They send a datagram-style message back and forth. We have tasks, which sound like Unix processes, but are not quite Unix processes. They're really only for organizing things at this layer of the operating system. As we'll see later, every BSD process does have a Mach task. Every POSIX thread is actually a Mach thread. And then virtual memory, which at the time was still kind of a new thing. The virtual memory subsystem itself was actually taken by the 4BSD project since it didn't have virtual memory of its own, so that still lives on. You'll see these same abstractions in some of the BSD kernels. All of the code is different. You couldn't look at one set of code and even reason how you got there from the 4BSD project. But it's also the reason why if you ever buy a PlayStation, if you ever look at the booklet they give you, there is a bit of license for the Mach operating system in the PlayStation I forget which license Mach used, but it's there because PlayStation's based on FreeBSD. FreeBSD being based on 4BSD took Mach's virtual memory implementation. Okay, so ports. Ports really are the standard way to communicate, very object-oriented. You could think of it as an opaque abstraction over a kind of message queue. I send you a message, and some thread of execution is listening on that port and then receives said message. And this is really what makes Apple's XNU kernel distinct from the other monolithic Unix-style kernels, because when you have ports, when you have threads of execution and you're doing message passing, you're able to design your kernel in such a way that you can have monolithic bits that don't need to grow. And when you need to communicate with another service, you can just stand up a port and just send it messages, and those messages will be responded to in time. The only other thing I'll mention about Mach while we're here, at the time, one of the other systems I support is BlackBerry's QNX operating system, another microkernel, really much more of a true microkernel than what we'll find out here with XNU. But Mach messaging was slow. Part of the reason I think Mach, and the reason for that is you've never taken a class on operating systems. When you message out of user space into the kernel, you have to do a context switch. So when everything is message passing, that means you're doing a ton of context switches. As we'll see when we get to the BSD server, the reason we'll call it a server, maybe even a subsystem, is Apple decided to integrate that into kernel space, so the message passing doesn't go from user space to kernel space as much. It still does happen, and I'll show a little bit later in some future slides looking at device drivers where you can see where that happens, and then you'll see what the cost is of doing that. XNU BSD. So again, I'd hesitate to call this FreeBSD. If you ask anyone in the FreeBSD community, they'll tell you it is. I don't quite buy that, but XNU being not a true microkernel. So again, QNX, there's really just a microkernel. Everything else is in user space. When you look at XNU, there is a BSD server integrated within the microkernel, again, mostly for performance reasons, I think initially. The hybrid architecture ended up being super successful because it lets you keep your trusted compute base inside of the kernel, so you can rely on the kernel to be a trusted execution environment. Some of the other microkernel projects, you can't say the same. You have to try to secure user space, which is in itself just really a different challenge. A thing you'll notice about Apple's kernel, and I'm still scratching my head why, and I've worked with some people who used to work at Apple, and they kind of explained it to me. But Apple doesn't have jails, which would be the BSD-style container system. And the thing about that is, I think containers can be escaped, and so Apple's thing is, well, they believe they can provide, full kernel virtualization, and that's better. If you escape out of the jail, you don't actually impact the host system's kernel. I think it's a major miss. Since then, other technologies have come up over time, sandboxing, other ways to try to isolate applications that Apple employs. But if you're used to containers and you wanted to do something similar with containers, up until about 3 months ago, you really had no way to do that on macOS. Today, Apple is shipping Linux containers as a part of their implementation. They have an open source Swift containerization library where they have their own super small Linux container. They've, I think, disabled most dynamic linking, and they use their own custom BusyBox, their own custom init system, all of which designed to minimize the security risk of running Linux containers. They really would like you not to escape the container. And then the IO kit, again, character interfaces. So a few decades ago, when you talked about object-oriented programming, a lot of people talked about message passing. Nowadays, when you talk about object-oriented programming, people think Java, polymorphism, stuff like that. Alan Kay, I think he had a quote, and I should have included it here, but he said when he recoined the term object-oriented programming, he messed up by focusing on objects. He said message passing was really what should have been the focus. And so here, this IO kit, again, object-oriented interface, you send messages to the kernel. IO kit itself, since Apple kicked us out of the kernel, it's almost useless. They replaced it with a new framework called Driver Kit, which does run in user space in a special sandbox of its own. And the way that works is when you write a USB driver, PCIe driver, Apple does two things. They start your user land process, but they also create a shim in the kernel. And what you do is you actually end up, if you want to send a USB tag, you create the tag in user space, they do some memory mapping between user space and the kernel, and then you go ahead and just send that message. That's actually really slow. In the grand scheme of things, it's a lot faster. Apple has a great hardware team who optimizes how the kernel works and this message passing, their inter-process communication, because they know it's so fundamental to the kernel, but it is slow. So IOKit's kind of a legacy thing. It's still there. It's Apple only. When Apple wants high-performance drivers for their hardware, they do ship an IOKit driver. For the rest of us developers, we're doing third-party drivers that run in user space. Other various kernel subsystems, everything you expect to be there is there. I didn't see too much point in going to any of these in detail, but there's power management. Apple has their own scheduler. The BSM audit subsystem comes from Solaris. If anyone ever worked on those systems, a lot of innovations in operating systems that we use today come out of those. For macOS only, dtrace, and then the rest of the operating systems to include macOS have kernel tracing. Dtrace is nice, it's user-facing. It's sort of like eBPF if you took away the ability to kind of authorize and deny kernel actions, just use eBPF as a tracing mechanism. Dtrace is more or less there. Somewhat similar designs, small state machines, code that gets compiled into the kernel dynamically, really interesting technologies. And then Apple's cryptography. The place that Darwin really shines, I think, as an operating system today is how much time Apple's invested in hardware, software, cryptography. Their secure enclaves. Back when they were running Intel chips, they had their T2 chip. All of these are custom Apple cores designed to work and really provide private key management. To this day, developers, if you ever have code that you want to run on that particular Mac and you never want it to leave that particular Mac, Apple does provide a solution with hardware keys tied to the computer. RTKit. So Apple has a second operating system that they don't talk about very often. It's called RTKit. It's a real-time system. It's entirely proprietary. A lot of folks have done a lot of research into reverse engineering it. The reason it's important to this conversation is processors have changed. Over the decades, we used to have one processor. That abstraction is still great to think about, your main application processor, the thing that is Unix coming up on your system. Our computers look wildly different from that. That is all a sham. They're very complex systems. Apple's pulling much of the stuff that actually interacts with hardware out of the Darwin operating system and moving it into their RT kit. Again, proprietary, but real-time. Darwin itself is not a real-time operating system. And that's actually a little bit different than other microkernel-based systems. Things like QNX are real-time operating systems because their abstraction, that opaque message queue, does priority inversion. So I send you a message, I'm the top running priority, I send you a message, you immediately respond, now you're the top running priority. Apple doesn't do that. Their message queue is asynchronous, so no real time, and real time is very important for controlling these SoCs now with the level of sophistication that they have. And then hardware. Some of this, I think I've already mentioned QNX, even L4. There are other microkernel projects that are still going today, have done really well. If you're running an Android phone or an iPhone, you're running L4 somewhere in your phone, your tablet, et cetera. Apple, so with Mach being slow, a lot of this relies on Apple's hardware team to optimize. So Apple for years has invested in their own architecture. There was about a 15-year window there where they were doing Intel. No more. 2019, 2020, they switched to Apple Silicon, and now they have their own ARM architecture that they develop, fully compliant with the ARM standards. Certainly a ton of micro optimizations, most of which are not open source. Again, it's all available on the machine. If you're willing to learn some machine code, you can take a look and get an idea of how it works. But Apple now has integrated hardware, and again, for a system like this, a system that's going to do message passing in and out of the kernel, it's almost required. Again, QNX is able to do it, different design. For Apple, hardware optimization kind of erases all the stuff in software, all the cruft that's accumulated for the last 40 years. Okay, so that's really it for the kernel. High level, Mach microkernel. BSD on top provides the Unix process model. Apple's own customizations, the object-oriented input-output kit. There's not much to say. Kernels are huge. You couldn't cover it all in 45 minutes. I worked with a gentleman who retired from Apple recently, and he told me, Kory, no one knows the entire networking stack, let alone the kernel, right? So high level, but really interesting technologies. Again, long history. This stuff predates Linux by about 13 years. Okay, moving forward, let's go over to userland. So the last thing I'll say about the kernel, so those fundamental kernel abstractions, in this case for any operating system, really have an impact on how the userland is developed, and you're going to see that here in the sections that we'll take a look at. So overall design, so again, object-oriented, and again, this is not polymorphism. I mean, that's there, that stuff's in the kernel, and the vnode APIs, et cetera. This is message passing. Apple does not believe everything is a file system, so that's probably a huge change for folks coming from Linux. No proc, no sys, and what they do have, a lot of the stuff is shims for trying to bring over BSD compatibility APIs. Apple really, recent years, has moved from using the file system, and the reason mostly is protecting the file system under the standard Unix APIs has been like ineffective for like 30, 40 years at this point. So when you have a socket or something like that that people then can go try to read, write, inspect, open, all you're doing is opening up a door for someone like me who has a hacker background to go, start fuzzing messages, seeing if I can impact your service. So Apple, with their Mach IPC, which really is very similar to Binder, if anyone's ever worked with Android, has an interface generator, sends the messages, again, no file system exposure. That's really the heart of what Apple does. That predates that you use a lot of daemons. If you have no file system, nothing like that that you're going to use to store your configuration data, updating data, you have to store stuff in a daemon. Now, ultimately, behind the scenes, that stuff is still stored to the system. It's still a Unix system. It's still BSD underneath the hood. Apple would just prefer you not know that or interact with that. Removing GPL code. So this, it's not just Apple. All the BSDs in recent years have really been very pressed to not do GPL. So for the BSD community, there is the BSD license, the MIT license. And part of it is if you want code that you can sell, it's really hard to make that code GPL under some circumstances. Again, I'm not a license expert. But to do that, Apple moved away from tools like Bash. Bash is still installed. It's a much older version. I don't recommend you use it. They moved over to ZSH, and then for decades, Apple used GCC, and that is no longer the case. They've all moved over to Clang because Clang is permissively licensed in the sense that Apple can take their ball and go home if they ever need to. And again, partially open source. The XNU kernel and much of Darwin, but not all, it's available, open source.apple.com. But really, I think the takeaway from this bit of information is, again, Apple really prioritizes moving away from like the classic Unix way of doing things. They want you to do things their way, which is object-oriented, daemons, et cetera. And then the code they want is really BSD license code. Apple does contribute a lot to the open source community, particularly FreeBSD. They sponsor their conferences, things like that. But they want to be able to take their code and go home. The other impact that it has on kernel code is that when Apple sponsors, some code we'll look at a little bit later, the security frameworks that many of the BSDs use, particularly FreeBSD. When Apple sponsored that, they made sure to get something that they thought was fundamental structures, like fundamental layer for that code, but no actual system policy. Some folks wrote SE Darwin, the equivalent of SE Linux for Darwin, and Apple was like, oh, that's cool, thank you. We want nothing to do with it, though. We just wanted the fundamentals so we can write our own system policies. Release cadence. This is what keeps me employed. Apple releases an operating system every year, and they are very aggressive with how they deprecate technologies. You usually, being a developer, I've been working with Apple stuff since 2018, you know they're getting ready to deprecate something when they stop talking about it. Because they don't come out and just, oh, we're going to deprecate that. They'll come out with something that'll be very exciting. You'll get the updates year after year. And then one year, just no update. Then the next year, no update. That'll go on for 4 or 5 years. And then one day, you'll get the deprecation notice. And then the APIs will be around for another 4 or 5 years. But Apple normally will provide some kind of replacement. So a recent one I can think of is the BSM, the audit system. They had an implementation that, again, very similar to kind of what you would do with ePPF with authorizing certain actions in the kernel, reading, writing file systems, et cetera. They took that, deprecated, replaced it with their own modern thing, endpoint security. The framework is still there. I'm actually working on an application now that I actually probably just committed last night, the last change to remove the last bit of that audit token code. But it's still there. It just gives you a lot of warnings when you compile. At some point, they will force you to get on the modern framework, so it's easier just to kind of keep rolling along with them as you can, depending on the size of your team. There are not very many macOS developers in the world, so that's often easier said than done. And then the yearly release cadence, it's really interesting. It's really more of a commercial thing than it is, the BSDs release when they're ready. Linux, if you were just in the last talk, I think they said Linux releases every 6 to 12 weeks, somewhere in there, at least for the kernel. I know certain operating systems like Fedora, I think Fedora does twice a year, Debian's on the when we're ready kind of schedule. Yeah, again, it's very aggressive. And so every June, Apple announces the Worldwide Developer Conference, and you get excited because there's some new stuff coming for you, and then you also look at your current code and say, oh boy, my manager's not going to like that, I got to go replace all this stuff. The developer toolkit. So again, Apple being a comprehensive operating system or vertically integrated, all of this stuff's included. It's sort of free. I think it's $99 a year for the developer membership. But they have their Xcode IDE. It's okay. Some of the tools are really good. It can be a little bit bloated. Again, we're talking about 30, 40-year-old software. It needs some modernization. But for the most part, you'll get the job done. Much of it's based on LLVM Clang. Apple does not use CMake. They have their own build system, which again, I've done a few rain dances at 1 in the morning to get stuff to finally compile after I flip the switch. The languages. So Apple, Objective-C should have died like 30 years ago. And Apple, for whatever reason, decided to keep it around. And I know the answer is, again, their design philosophy. Objective-C was a message-passing, object-oriented language based on Smalltalk. It really kind of jived with what Apple had going on coming out of Mach. At the time that Steve Jobs started Next Step, I believe the folks from Objective-C were, like, that company was just wrapping up. Folks were looking for jobs, and they were available. And so, but its legacy, it's a reverse engineer's dream. Objective-C, when you compile it to whatever your assembler is for your platform, it stores the class information and all the function names just in plain text, exactly what you wrote. And it's always, I've always loved it from a hacker's perspective, maybe trying to secure systems, information you wouldn't want. Hand in the back.
Yeah, I heard some rumors that Apple's quietly replacing Objective-C with Rust.
You know, so I follow Apple's job hiring page, and I have seen Apple saying, hey, like, we're looking for people who have Rust skills. I can't speak to it any further. I do know, like 3 years ago, Apple really started ramping up hiring Linux developers, and so I knew then, I was, oh, something big's coming with Apple. I knew they weren't going to replace Darwin, but adding Linux in somehow, and lo and behold, this year, they were like, yeah, we're ready for you guys to see what we've been doing. Apple doesn't control Rust. I couldn't see Apple ever switching to Rust without it being a language that they more or less kind of control. And the thing with Swift, it came out of Apple. It's now open source, runs on Windows, Linux, even FreeBSD. Apple has a majority of like the development team and all the direction and et cetera. It is open source. You can actually contribute to that. But I just couldn't see Apple going with Rust. The person who created Swift, Chris Latner, he created the LLVM project. He took inspiration from Rust and was well aware of it, but they wanted something that I think was more application focused, whereas Rust, maybe in device drivers someday, but yeah, I haven't heard anything like that. Yeah, who knows? Rust is an interesting language. I personally, I'm a big C guy. I'm not a big fan of C++. If Apple decided to go, Apple has no less than 4 versions of C++, so they have standard C++, the IOKit C++, which is embedded C++, no standard library, like not fully featured C++. The metal shading language here is also in C++. They've got like 4 different versions of it, and none of them are very good, in my opinion. But that's more about C++ than it is, the direction Apple's going in. So Swift is Apple's modern language. It's what they prefer for new apps and where they're pushing folks. Fully interoperable with Objective-C and nearly there with C++, almost. It's really grown in the last couple of years. So Apple's going for I think, a full replacement of both Objective-C and C++. And? There you go. Yeah, Swift and Rust are very similar. They achieve similar memory, safety, object-oriented goals. Swift, I think, is just a lot nicer to write in. No borrow check or anything like that. The semantics of the language are a lot cleaner. You got value types, you got reference types, and you know what to do with them. Moving on, package managers. Apple does not ship a general package manager. You have to go get that from a third party. No one knows why. That's just the way it's always been. Homebrews are a big thing. It's probably pretty similar to APT and whatever Fedora has going on. Not very secure. I do not, normally when people ask me to do a security assessment of the Macs that their developers are using, if you've got Homebrew installed, you have a security vulnerability somewhere. You might not know where, but it's a community-run thing. It's really awesome. I'm glad it's there. Apple should probably have a secure first-party solution. I don't know how that would work for them, though. Common file formats. So you won't see a lot of JSON in Apple's stack. Property list, XML, that's their big thing. That's the thing that everything communicates with. In recent years, Apple has also shifted, so they have this .app format, which is just a file structure on disk. Your Mac apps, your iOS apps all ship as .app. In recent years, Apple is trying really hard to, they have a PKG format installer where developers have been using to ship their third-party apps for years. The writing on the wall is that technology is done. Apple doesn't talk about it. They don't write about it. They've taken the articles down about it. They want you to ship everything in just a directory, a high-level APP format. There's info plists, other things that describe, kernel extensions, frameworks, everything basically ships as a .app. Again, it's BSD. All the BSD stuff is still there. Apple just would really like you not to use that. They want you to use their stuff. They make it harder sometimes to use the BSD stuff. And again, not for bad reason. It's nice to have a standard. It's nice, as a reverse engineer, even a software developer, it's nice to be able to look and know, oh yeah, the binary is going to be here, the supporting files are going to be there. It does have its benefits, but it's certainly Apple's own custom thing. Okay, I have to speed up a little bit. So LaunchD, which inspired systemd. LaunchD is much older than systemd and really has a special place for Apple. So with Mach, you have all these microservices running in user space. How does one service know to talk to the other? It's like a fundamental problem. And back in the day, they had something called the Mach Bootstrap server. It's really more of a position something takes now. The init daemon LaunchD serves as that Bootstrap server. So it comes up first. Every process that gets launched on a Darwin machine gets a mock port, and that mock port lets you communicate with this Bootstrap service, and you can ask it for other services. And it's kind of how the inter-process communication works. Otherwise, you would have to use the file system to do some kind of service discovery. Much like System D, it continues to grow. It gets bigger and bigger every year. Apple adds stuff, and this is one of the pieces of Apple's system that is open source, and then they close source it, and then they open source it again, and they've kind of gone back and forth with if they want developers to be able to look at the source code for this. So there is a version of this, much older, that if you're ever doing a mock-like system, it's there, you can modify it. System extension D, this is a relatively new daemon. So again, the problem with microkernels, when you're running everything in user space, how do you protect them? And with the launch D, much like System D, you have an integration lifecycle, things come up, go down, you have tools to manage various daemons and services. And so for Apple security software and their system policy, that doesn't quite work. So they've added a second daemon that launch D launches. It runs under Apple's system integrity protection. That's the thing that protects Apple's file system. But it is becoming, again, in itself, a much larger daemon. But device drivers, endpoint security, which again, that's our version of eBPF. All of that is actually managed by this separate daemon. I do a lot of enterprise deployments, and this is really the only way you can protect your software from just, most Macs that ship, the user, controlling the Mac has local root access. So if you're doing something like data loss prevention, insider threat risk software, you have to have some daemon, some way to exit Apple's normal daemon application lifecycle, and then there's something that Apple can secure, and that's what they use the system extension daemon for. No Pipewire, no other daemons like that. Apple vertically integrated. It's their own custom stack. They have their own graphics stack, all of that. They certainly draw a lot of inspiration from the open source. Security. So Apple has the basic POSIX security model here. Everything you would expect, access control list. I think they support both common standards for the ACLs, if I'm not incorrect. They have their own cryptographically signed boot environment, so you can't run just any version of macOS on your hardware, though you can run Fedora Linux. Apple worked with the folks from the Asahi, if I'm saying that correctly, Linux team to get Fedora running really well. And then I think hired some of those folks away, so we'll see where that project continues to go. Okay, we're getting a little short on time, so I'm going to speed through the rest of these. This one, sorry for so much noise on the slide, but this is Apple's extended thing. So the one thing I think that's super important is the BSD mandatory access control framework. It's similar to Linux security modules. I think, and this is the one thing that I think the BSDs probably do a little bit better than Linux today. Apple runs 6 to 12, maybe 18 system policies on your Mac, and the BSD mandatory access control framework doesn't have some of the same issues. If you ever tried to run AppArmor and SE Linux on the same machine, you're going to run into some problems. I think some of that's been fixed in recent years, but back in the day when I was doing it, we certainly ran into problems. The BSD Max compiled into the kernel. It lets you run however many system policies you like. It's object-oriented. It just calls them in a row. So you'll have policies for the root user. You might have policies for a set of daemons. You might have policies for a set of folders. It's really flexible. And again, folks at the time that this was created the SE Linux equivalents, but those aren't popular in use. Built-in antivirus software, they have XProtect, that's their YARA rules-based antivirus. Gatekeeper, anything you download on your Mac, if you ever look in the file's extended attributes, until it's been scanned by Apple, it has a little bit of data that says, hey, this has been downloaded, I'm not sure it's safe. Apple's keychain, transparency, consent control, mobile file integrity, which is actually another mandatory access control framework thing. Apple code signs all their software. Not all. I guess you could run BSD software without code signing it first. But if you're distributing applications trying to make money or want to go to Apple's App Store, you have to code sign. Apple uses the Mach-O format. It's sort of similar to ELF, designed to be a little bit more extensible. They just look at the parts of your binary, all the text sections that aren't going to change, and they just kind of hash them all, cryptographically sign it, stamp it on there, and check it when it runs at runtime. I've been saying Darwin. There is not a thing that you can download or you could run that is the Darwin operating system. Apple has these slight differences in kernels, user space, particularly iOS, watchOS, tvOS, and visionOS. Everything that's not macOS on the screen is very restricted. So as a developer, I can't call fork. which is really odd if you're coming from any other Unix world. Why can't I call fork? Because Apple's decided that forking is bad for embedded operating systems. And fork still works. It certainly has the fork stuff itself, but it's just a more constrained kernel. Okay, hit time. Oh man, that was gonna run out. All right, a lot of information. I know it's really hard to cover a kernel in 45 minutes, but any questions, thoughts? If you yell it, I'll repeat it.
You said like open source is available, but it's really hard. At least for the kernel, like if I want to tinker with it, like, is there any way I can just start with like, yeah, I understand the hardware stuff, and start with keyboard or something?
Yeah, you can get the kernel. There's a kernel development, a kernel debugging kit on Apple's website that you could start and get it tinkering, and that would work just fine for you. Over the years, there have been multiple projects of people taking the open source from Apple and trying to build an operating system, but one of two things ends up happening. Either one, you actually get it running, and then Apple makes you an offer you can't refuse to go work in Cupertino, or two, there's really no point in creating a Mac OS clone. A lot of people will do these like clone projects, and I've got a Mac right here, I don't need a clone. I need maybe something different. So, but yeah, you can get the kernel, particularly for Mac OS, you can build your own, and you can get it running, and it semi-works, but you won't be able to get it installed on hardware. But Apple has their virtualization environment. Anybody else? I have, so my thing is, when I look at operating systems, I have to be able to point and look at probably 100 million installs. So like when I got into FreeBSD, it was because Sony uses FreeBSD for their Orbis OS. I haven't done Redux. I think the thing for me is, if it doesn't have 100 million installs, it's kind of like a research thing for me, and then at that point, I can look into whatever variation of Linux and the new stuff coming out. So I haven't looked in, it's just not big enough to where it's hit my radar just yet. Sure, yeah. Well, so APFS is actually still compiled into the kernel. The operating system, Apple provides APFS and HFS Plus, and those are both compiled into the system by Apple. Last year, maybe a year before, they released their file system kit, which kind of extends the mock idea of running everything in user space, where they released the ext4 on macOS is actually implemented in user space. So I don't think APFS really had too much of an impact. APFS, if you don't know, it's kind of like BetterFS, with the big glaring omission that Apple doesn't ship any device with multiple disks. Therefore, their system has no multi-disk support that you would find with BetterFS or ZFS, right? And so, yeah, the APFS, it's a great file system. It was created, if you ever looked at the B file system from 30 years ago, maybe 20 years ago, the designer of that file system, I believe, is the gentleman who designs Apple's. But yeah, it's all in the kernel. So Apple, again, kernel for Apple, not for the rest of us. If you do use Apple's FS kit today, you could not implement ZFS or BetterFS because Apple doesn't allow you to have more than one disk attached. So that is kind of a limitation. But yeah, FS kit's a new thing. Apple hasn't really talked about it too much, and it's just not complete today. You could do older systems, though. Sorry. Any other questions? I know we're extending the lunch a little bit.
Isn't there a server factory opening up here north of Houston?
I don't know. I haven't heard that. I'm in Dallas, so I don't know if there's a local rumor. From Apple, an Apple server factory?
Apple servers that we manufactured out in Houston, I heard.
Ah.
I don't think that's any United privileged information.
Yeah. Well, Apple hasn't shipped. They used to have macOS Server was the first version of OS X to come out, and they haven't shipped that in years. They now have their private cloud compute, which is really based on iOS. It's supposed to be this place where you can go do AI and other calculations, and it's under some form of confidential computing. It wouldn't surprise me if, I mean, they have, I think, a decent presence down here in Austin. It wouldn't surprise me if they need to have some server somewhere. They must be. I imagine that probably runs on Linux is probably the actual hypervisor there. I don't know, yeah. Okay, I think that's it. Thank you very much.